Hey, what's up guys? My name is Jaden. I'm a 4th year kinesiology student, and today we're going to be looking at the Santos program. I'm going to be introducing you to some of its basic functions, and then I'm going to walk you through how you would use it in your lab. So when you open up Santos, it should essentially look like this. You have your expert pane window, which is going to show you all of the objects that are contained within your world, and it's also going to show you some of the properties of that object. You have your library window, which is going to show you avatars, models, accessories, animations that you can quickly import into the world by clicking and dragging it. So we're going to do that with a cube. Now the camera controls can be tough to get used to, so I'm going to explain it real quick. You're going to hold down the spacebar and left click on the mouse to rotate the camera. To zoom in and out, you're going to hold down spacebar and then scroll the mouse wheel. And then to translate the camera, you're going to hold down spacebar and click the mouse wheel. And this allows you to translate the camera. Now for object manipulation, you can move the object with the arrows. You can also just hold down in the middle of the object and drag it around. You can snap the object to the ground by clicking on the snapping option and grounding it. And this means that when you move the object, it will always stay connected to the ground. You can snap it to the grid as well, which means it will stay connected to the grid lines. And then you can also snap it to another object and they will stay together. Now, other than translating an object, you can also rotate it by clicking on the rotate option, and it allows you to rotate through the different axes. And you can scale the object by clicking on the scale option, and you can make it taller, wider, deeper. Now for avatars, you would bring it into the world the same way as an object, and you can do the same translating and rotating. You can also use the joint manipulation tool in the toolbox, and you click it and you highlight over the avatar. It shows you all of the joints that are available to manipulate. So I will double click on the shoulder and it will show me all of the planes that the joint can move through. So you can scroll through these by scrolling on the mouse. Green is going to be my extension and flexion of the shoulder. You also have red, which is going to be internal and external rotation. And then you also have blue, which is going to be adduction and abduction of the shoulder. And for the knee, you only have one plane that it can move through, flexion and extension. So it's only going to have one option, similar to the elbow. So for the lab, Santos is going to be used to predict and analyze the forces that would act on the body during specific tasks. So this is going to be done using the spine shear and compression analysis tool. And first we're going to have to import the model for station 1. So we're going to go up to File, Open, usually in Downloads, and we're going to select Pushing Wall Example. Now we have a recreation of Station 1 in Santos. Now before we do any type of analysis, I want to make sure that our weight for the avatar is correct. We want to use the 50th percentile female. So we're going to go to weight gender, going to click female. The weight percentile, we're going to type in 50. Now that our weight is set correctly, we want to make sure that our units are correct as well. So we're going to go up to project, global units and scale, and the metric system measurements are going to be in centimeters, angles in degrees, and weight is going to be in newtons, which is important to note. Now we're going to expand the avatar in the expert pane. Going to expand point loads. Now point loads are going to be used to show the reaction force that would be applied to the person's body when doing this task. We have one in the left hand and we have one in the right hand. So we want to note that right now it's at 90 newtons in each hand, which is going to mean that the combined hand load is going to be 180 newtons. So when filling out this table here, we want to look at values with a combined hand load of 0 newtons, 50 newtons, 100 newtons, 150 newtons, so on. So for the first one, 0 newtons, we're going to type 0 for the right hand and 0 for the left hand. Now to look at how the spine is being compressed, we're going to go up to Tools, Visualizers, and we're going to click Spine Shear and Compression. So this analysis tool is going to give us the values that we're going to use to fill in the table. So at 0 newtons for combined hand load, we're going to have a flexion and extension moment of negative 27.27. We're going to have a twisting moment of 0.73, a lateral bend moment of negative 0.93, an anterior-posterior shear of negative 83.17, a medial-lateral shear of 6.61 newtons, and a compression of 1,100.79 newtons. Next, we're going to analyze for 50 newtons of a combined hand load. So this means that we're going to change this to 25. I'm going to change the right hand to 25. Now it's a combined hand load of 50 newtons, and we're going to do that same thing when filling out the table, and you're going to continue that. So when looking to solve for the combined hand load value here, you would just play around with the hand loads until you got a compression of 2,700. So you could try 200 in the right hand, 200 in the left hand. Gives you a combined hand load of 400 newtons, gives you a compression of 1,800. So that's not high enough. Try 290. And that gets you pretty close. And you just keep playing around with it and adjusting the numbers until you found 2,700 compression. So for station 3 of the lab, we want to open that file, downloads, and we want to choose box lifting start. Now that we have a recreation of that task, we want to recheck our weight of the avatar, put that at 50th percentile female. We also want to recheck our units, measurements centimeters, angle degrees, weight in newtons, perfect. Now when filling out the table for station 3, we want to note that the combined hand load is in kilograms. So to change these hand loads from kilograms to newtons, we want to multiply by the force of gravity, which is 9.8. So for the example of 5, we can go 5 times 9.8 equals 49. And we're going to divide that by 2 to give us the hand load for each hand, which is going to be 24.5. 24.5 newtons. Now we can analyze the spine shear and compression and then fill these values in to the table. So flexion extension moment of negative 60.84, twisting moment of negative 2.5, lateral bend of 6.23, anterior posterior shear of negative 182.77, medial lateral shear of negative 23.16, and then a compression of 1,312.31 newtons.